Hello, class. Uh, Welcome back. Okay, to our second lecture clips. Continuation from our. I think I posted the last clip almost 2 weeks ago. Okay, and we are here. Okay, uh, from our lecture note sheet to this one that we end up having a formula, right? By using Gauss elimination, okay, to be able to find the inverse metric in partition forms, okay. And I think we also leave you to think about the 3 by 3. And also, we provide you with this compact formulas, okay, of this one, okay, in sheet number 16, okay, that once you were given the large matrix A being partitioned to 2 by 2 subsystem, okay, and you can find the inverse matrix through this computation, okay, that could. And the homework that gave you last time is that we want you to implement, okay. I think that we have given you this file, right, of metric partitioning, of solving system of linear equation with this given value of a11. Okay, you can see that this is given the a11. Okay, and then if you might recall that before I gave you the homework of finding the inverse matrix in partition form, okay, we starting with what we call the direct solving system of linear equation. Yeah, this one, right? If you see that we break down the activities, okay, you start with computing the A11 inverse, okay. So this one, sorry, the wrong sheet, okay. This one given A11, okay, of the size 1000 by 1000, and then we will be able to solve. This one is a formula, okay, as you might see, okay. I'm gonna try. See that. You see that the formula in Excel, okay, we call the M inverse, okay, of the above range of data of 1000 by 1000. And then we be able to, right, after you get the results, okay, it's depend on your Excel's version. Sometimes the whole 1000 by 1000 appear immediately in the newest version of Excel. If you want the old version, you need to expand the range of the output, okay, to equal the exact size of the output, and then you press Control Shift Enter, right, to expand all the results. This is what we get. That this one actually is the inverse of A11, fitting with the first procedure. The second procedure, we found A12 prime equal to A11 inverse times A12. That happened in the sheet 2. This one, we, uh, oops, sorry, too small. Okay, we zoom it a little bit more larger size. Let's see. This one is from the above data is A12, right? In the yellow shaded area, and then we have this is the result. Okay, this is the inverse of A11 times A12. We call A12 prime. This one we use the mmul, right? Yeah, metric multiplication command, and then similar. Okay, you need after the results, you need to expand the exact size of the output and press Control Shift Enter simultaneously. You get this result. So this one follow the second step, right? And then we move on to the fourth step first, because actually the third step, this one we this sheet 1, sheet 2, sheet 3, sheet 4, and all of this is in sheet 6. So number 4 is that we compute A12 double prime equal to A21 times A12 prime, right? This happened on the third sheet, okay, sheet 3, right? just the size was a little bit too small. Okay. Uh, okay. We this one A12 double palm, right? A21 time A12 palm. So this is follow. We refer to the A12 palm from sheet 2, right? And the range of A21 is above in the yellow shaded area. Okay, so this is the formula for A12 palm, double palm here, okay? And in sheet 4, we compute A12 palm, A22 palm, right? Which is A22 minus A12 double palm, right? So this is, we go on to sheet 4, right? And sheet 4 is with a given, uh, this one A22 minus A12 double palm. It's just an exact, you don't need any metric operation, just put it the first cell and row number column 1, and you can keep copy to row and to column, and they will with relative addressing system, right? So they'll be able to uh, compute this subtraction of the matrix easily. Okay, so this one, okay, is the given A22 on the above. And then in sheet 6, right? Sheet 6, this is the major part that where we get the results. Okay, you can see sheet 6, we compute B1 palm, we got B2 palm, and then we compute X2 and X1. Okay, but before we compute all of this, what we need to do is we need to compute A22 palm inverse, right? This is a requirement. We need A22 palm inverse. So you can see that the first thing that I did here, okay, since this is a back substitution, it starts from A22 palm, this one, in this cell, yeah, this one. This one is A2, recall to the A22 palm from sheet 4. This is the range, and then you put the formula of A22 inverse. Okay, so A22 inverse is over here, right? And then so you get X2, right? And then you need to compute B2 first, right? You need to compute B2 according to this one, right? B2 palm, sorry, B2 palm. And then once you get the B2 palm, you get this one, you get X2 inverse A22, this one. This is the range of inverse of A22 times B2. So use another metric multiplication, you get this result. And once you get X2, okay, once you get X2, you'll be able to get it. To get X1, you need to compute B1 palm, and then you need to compute A12 times X2, which is appear on the above back substitution process. This one you compute A12 palm times X2. Okay, select where A12 palm is in sheet 2, and X2 is down there in this sheet of sheet 6, right? So you use just a direct metric multiplication. So you get this one, A12 X2. And B1 palm, you need to compute B1 palm. This is B1 palm is over here. The inverse of A11 times B1, right? The inverse of A11 is in sheet 1, and B1 is in sheet or on the column C here in current sheet 6. So you get this. So you get B1, you get A12 X2. So this the X1 very easily. You just use this minus this, and then you copy all the results according to this formula, right? So and okay. Our question is that, okay, did you get the correct solution of x1 and x2 according to this one? According to this one, did x1 and x2 solve the solution? So we go back to the original partition system on sheet 1. You can see that you can check here. This is the right hand side, B1, B2 being partitioned here. And you have A11, X1, P7, 2, X2, P21, X1. You check whether left hand side equal to right hand side there. So this is what we did over here. Okay, on sheet 6 here. Okay. This is A11, X1 plus A12, X2. Right. Then You expand all the results. You can see the left hand side. This is the right hand side, the B1. All are equal, right? With precision of 2 digit, right? And then we go on to check the remaining of this one. A21x1 plus A22x2, right? This is what I repeat this part again because uh, this is such an important step, okay, that we refer before, okay, and the homework that we want you to do, okay, is belong to the implementation of sheet number 16 over here, right? You given the same results of A11, A12, A21, A22, right? And you have this formula of consists of inverse metric and metric multiplication. If you really understand the first five of the Excel here, okay, step by step, it will be very easy to do. And I did implement some example for you to see here. Okay, this is the new file here. Okay, we call uh, metric partition. Okay, 2 by 2 inverse metric, 2000 by 2000. Actually, all the file, the necessarily related file, I already share for you in this sub folder. Okay, within this one, that all of you, if you have the link, previous link, you can get this two program. The first program that I show you, this program, okay, the copy of matrix here, okay, is this file, right? And the new file that I will show you the result over here, we call them metric partitioning here, 2 by 2 inverse metric over here. This one we trying to implement. This file is a new file that I've been added here that you can download and take a look and learn and study. Okay, so we're gonna talking a little bit that how the last homework that I assigned to you, and then what did I implement here. Okay, you can see that this is the new file. Okay, oh sorry, I should start large here. Okay, and it consists of 8 subsheet. Okay, certainly the first sheet is A11. Okay, the original A11, and also I also copy from this file, this copy. The first 4 sheet is exactly the same. Okay, the difference is sheet 6, because in this file we trying to solve a times x is equal to b, but this file, okay, this copy, we just want the results of the inverse matrix, okay, which is recall to sheet number 16. Okay, we want this b11, b12, b21, and b22 of this inverse matrix. Okay, but you can see that you get A12 palm, A22 palm, and B22 palm. All of this is exactly, almost, not almost, it's exactly the same as what we did before on this step, right? You go A11 inverse, A12 palm, A22 palm, until A22 palm here, right? This is exactly the same, right? So that's why we, to implement this new program, the first 4 sheet, I just changed the name to A11, A12, this is A12, A21, and A22. Okay. As you can see that A11 is, okay, you have A11 value, it's exactly the same, and now the metric after A11, okay, is B. This is the inverse of A11. Okay. It becomes the inverse of A11. Okay, this one, you see M inverse, the same. And sheet 2, A12, okay, also certainly you can guess that exactly the same as the previous file. So you get A12 palm over here. Okay, A12 palm, exactly the same. This is the same as sheet 2. A21 is the same as sheet 3 from the previous Excel file. You get A21 times A12 palm over here. And A22 also, you get A22 palm. This one, A22 palm. So the first four, A11, A12, A212, is exactly the same as the previous file, sheet 1 to sheet 4. The difference is that the solving the linear equation, you need the platform of sheet 6. But to find the inverse, okay, according to uh, the formula, okay, that the live formula here, we need four results. One, you get B11, B12, B21, and B22. And the first thing that you can get is B22. Because once you be able to compute A22 palm, you find the inverse of A22 palm, it becomes B22 palm. So you can see that from this find a metric partitioning 2 by 2 inverse metric, the first find be able to find is B22 here. Because B22 here is just the we just easily, okay, find the inverse of A22 palm. You can see that A22 palm is in this sheet of A22. A2. So I recall the position where A22 palm is stored in sheet A22 and find the inverse. So now you get B22. So B22 is very quite easy, that just the inverse execution of 1000 by 1000. So this one you get B22. And after that, okay, after you get B22 here, okay, the easiest way is that you get B12. Because B12, you already have A12 palm on the sheet of A12, right? So you use just metric multiplication and multiply by -1. Okay, you get B12. So the next one of this file, you get B12, this file. Okay, B12. Okay, you can see that you get B12 over here. This one, minus A12 palm plus B22 palm. You can see that the minus sign equal to minus metric multiplication. And you know that A12 palm, the range of data is in the sheet A12. And then B22 palm is in the sheet of B22. So you just recall the range of the data in the Excel, where it's stored in which sheet, and then you get this and use the metric multiplication. And then you, as you say, if you're using the old version of metric, you don't forget to drag the range of the exact size and then press simultaneously Control Shift Enter. So this one you get B12, right? So these two sheet B22, you get the results B12, and then you go back and look at the formula here. You get B12, B22. But before you will get B11, you need to know B21 according to this form. So the next value you need to compute B21. But B21 you have to multiply three matrix, right? So and any of this multiplication pair have not been computed before. So there's two ways that you can go. You can use B22 times A21 first and then get the results and multiply by A11 inverse. This one is a forward approach. Or you can use the backward approach. You get A21 times A11 inverse first, and then you multiply this multiply metric results to B22, and then change the sign of minus. And then you get B21. Okay, let's see what did I do with my program. This one you get B21 first. We compute B21. Okay, for B21 require quite more computation over here. Okay. Oh, sorry. I should have. Okay. Okay. You can see that we start here. We use A121 times inverse of A11. See, you have metric multiplication. A21 is in the sheet of A21. Okay. And A11 is in the sheet. The inverse of A11 is in the sheet of A11. just pick assign the right location where the result that you want to do. So you get this A21 time inverse A11 first, which is you go back to this formula. This is a backward approach. You get A21 time A11 inverse first, and then you multiply the result to B22. Okay, and you get B22 multiply the resulting multiplication of A21 and A11 inverse. Okay, so you can see that from this sheet, okay, if I go downstairs, okay, I drag the range down, okay, you can see that B21 is equal to B22, okay, B22 is in this range, is in this sheet, okay, okay, so we uh, which is the inverse of A22 palm, okay, so you can see that we use the minus sign B22, okay, is where we get the results of inverse of A22 prime, and then multiply to, you can see that A21 time inverse of A11 is in this sheet of B21, but it's up, the range is up to this matrix from uh, B3 to ALM 1002, which is the above the shaded area here. That which is you can see that is the multiplication here of A21 time inverse A11. Okay, so this is how you get the results here. Okay, so you do this. Nope, I'm sorry, something wrong. Okay, maybe just press. Something is hanging. Uh, okay, I need to get. Okay, we don't change it. I think something wrong with my. So I'm gonna close it. Okay, first close this one. Don't save. You can see that the file is pretty large, right? Larger than the previous side of solving equation, because now you have 8 separate sheets. Okay, so this one I just gonna call it again. I'm gonna open this one, metric partitioning again. It will take some time for me, right? Because the file is very large. But you can see follow the whole idea that we can keep using this formula and implemented it. Okay, we're gonna wait until the results come out. Okay, not yet. Okay, have to wait for a while. Okay, you can see that the resulting file is much, for inverse, is much larger. I think it's almost twice, okay, of the size of solving a linear equation, because the resulting is another large inverse being partitioned. Okay, you need to keep several part of it, right? And how come not coming yet? Oh, okay, it's opening. Okay, okay. We while we wait the file to open, okay, we're gonna continue. Okay, now from this the whole part that I just been giving a lecture for you is a continuation from the last part of the previous clip that I left the homework for you. And actually I this is just a demonstration of that. Oops, why? Oh, it's not yet. Close. We wait for a while. But when you see the behavior, you can see that why it works so slow on my machine, because the file keep getting larger and larger. So it take a long time to communicate, to retrieve, and to to load it back to your main memory, because you put everything under only one file. And when you open it, you keep each metric partition separately, but in different sheet, but under only one file. Once the file open, I, even though it's stored in different sheet, it still cause you the problem that you need to have a storage that can take care of the every sheet simultaneously, which means that in terms of the inverse file, inverse metric file. Okay, now yeah, I got the results back. You need this 8 sheet, okay, of BA11, A12, A21, A22, B12, B11, B12, B22, B21. Okay, we are at the B21 here, okay. B21, I already show you that we get this A21 time inverse of A11 over up there, and then we move down to the second part here, you get B21 here. Okay, this one. You get this, the B21, which is the metric multiplication of the shaded area both as a the origin have to be B22 times the resulting metric multiplication of the shaded the blue shaded area above. Okay, in this sheet, right? And then you get this result of B21. Once you get B21, finally, right, based on this formula, you get B21, you get A12 palm times B21, and then minus A11 inverse, right, and you get B11. So that's the last part, and the final that we need to compute is the B11. The B11, okay, the very first thing that you need to do is to find A12 palm times B21. You can see that A12 palm is in the A12, the sheet of A12, okay. And then B21, okay, certainly is in the sheet of B21, okay. So you multiply this A12 times B12, B21 first, okay. So this is the one you multiply, and then you subtract from A11 inverse. So the the results end down here, okay, after you pass halfway. Okay, over here you could see that, you see B11 inverse of A11, inverse of A11 is in the sheet of A11 over here, right? And then minus A12 to B21, A12 and B21 is in the B11. You can see that since this is a matrix subtraction, you can start from the top leftmost, okay, and then you subtract them, and then you can copy to all the row and then copy to all the column, okay, or to all the column first, and then double click for all to cover the possible row. So you get this, okay, to be the results of B sub 11. Okay, actually I forgot to say, actually here B sub 11, B sub 12, B sub 21, and B sub 22. I forgot to talk to have what we call the uh, what do you call the adjective, okay, of the noun, right? Like the B, actually B11 is B subscribed 1 okay, okay, subscripted, right, subscripted 1, okay, okay, and in short we normally call B sub 11, B sub 12, B sub 21. Okay, but in the Excel file I didn't use the subscript, so I can say the B11, A11, A12. Okay. Okay, so that's how this homework can be implemented. But there's still open room for you to improve. These two files, okay, that I gave you, okay, is a type of file we call all-in-one, which means that they want to implement this concept in one file, one spreadsheet file. And also, they want to implement this work breakdown structure of 2x2 system in just one file. And you can see that I already showed you that there we have the problem of communication. It takes a long time to reload the program back or even to save the program sometimes. So what is the other way around? Okay, okay. The other way around is that suppose that for each partition system A11, A12, A21, A22, I save in the separate file. Okay, you have the separate file, uh, not the single file, but different sheet in Excel. This is what we do for you. These two files, this file and this file is only single file, but all in one. All the partition part keep in different sheet, and it doesn't work very well. And because when once you open the file, they utilize your main memory simultaneously. All the partition part not really being exploited or taking it any advantage. Okay, so this is how we go back to the my drive, and then if you look at the share drive of all information I gave you, we have a subfolder called Excel file here. Okay, and if you double click here, okay, in this case I expand it to like 3 by 3. Okay, but if you really consider for the system of 2 by 2 first, okay, you can start with this one, the file of A11, the file of A12, A21, and A22. Okay, okay. Actually, I have this file in my hard disk. Okay, I'm gonna open it for you. Okay, you have A11 over here for me. Okay, I have A11. Yeah, this one. I have this A11. Actually, this file is the same as this one. You can download it here. And I have A12 also. I can open. Actually, you have to download from my share drive to do this. I have A12. You have A13, A12, all of this here. Maybe I just open one more file. I have A12 separate here. Okay, so now I have 4 sheets. You can see that the difference is that I separate each partition metric in different Excel file. But the previous one that the work that I did for you is that I put everything in one single file, but saved each partition part in different sheet. It is good for illustration for you, but it's not very efficient way to work on, because you didn't utilize the when you partition the large metric to smaller metric. The reason why you partition large metric to smaller metric, you expect that you can working on the smaller metrics and then once at a time, while you're not utilizing your remaining memory on other part of the matrix, which means that the other metric might be the file that's stored in the hard disk. Okay, so that's why this is a continuation of the assignment. That in first you need to study these two files of the copy of the linear equation, and then I explain you everything about this file, the metric partitioning. Oh, sorry, this one, metric partitioning here. Okay, but these two files, all A11, A12, A21, A22, okay, keep in the same file, single file, all in one. But I have this drive of share Excel file that for each partition metric is keeping separately. Okay, like in this one, A11, A12, A21, A22, like this whole file. But actually we have up to the 3 by 3. You can see that up to, but let's consider based on what we have learned so far is 2 by 2. A11, A12, A21, and A22. The example is over here. The difference is that it's the same number, but more accuracy on the number of digits. You can see that the previous value that I generate for the test problem up here, okay, you can see that A11 is only 2 digit accurate, right? You can see like this is 9.53, okay, 8.90, 9.335, 9. It's only 2 digit, but the the new file of A11, okay, and A12, A21 that keep separate file is more accurate, like in the 3 digit. Like the first one, you can see that instead of become 9.721, 10.432, 3 digit accuracy. Okay, so the data is different, but the size of the problem the same. Okay, and you can think about this, that how can we apply this? Like instead of now, you can have, but certainly for each file here A11, I haven't compute A11 inverse yet. And this one, and A12, I didn't compute the multiplication of A11 inverse times A12 yet. So this is just a purely input data file. But you can think that you can also implement each file separately, okay, one at a time, and then transfer the necessary result to the next file, okay, and then just compute each file of this one A11, A12, and just like what you do previously in like in this in different sheet. Instead of different sheet, become different file. And then this one, you can see that for solving the solution, you have an extra file, the fifth file here, sheet number 6, according to the fifth file, to compute the value, to compute all the x1 with the vector of x1 and vector of x2. Okay, and the same thing about the inverse metric over here. Okay, that instead of you have all 8 sheets, put it into one file. Can we implement the same things that resulting in the 8 different file? 8 different file. Okay. The reason why we looking for this type of approach is that uh, we expect to save more memory, because in each file we're gonna implement on what computing necessary. Okay. Instead of you have to share so many memory of some part that uh, like in the single file, while you're working on one sheet, the data in other sheet also occupy your memory, right? But in for this one, each of them uh, can be open one at a time. Okay, sometimes you need to open one or two files at the same time, but you don't need to open all of them at the same time. Okay, that's gonna help you in terms of uh, you're not creating a very large file. But the weakness of the approach is that you have so many communication. You have to open save file, then you have to copy the data from one file and use it in some file, some other file. You cannot just also refer to the location of the data because it's not on the same file. It's in the different file. If it's the same file, different sheet, you can also, when you're trying to multiply the data, or when you're trying to find the inverse of the data, you can also refer the location of your data in different sheet. But once you have separate file, you can't refer the formula, the data from the secondary storage to work. So therefore, like once you get A11 inverse, you need to copy the A11 inverse to the file of A12, right? Because and then you can multiply them under the same sheet, right? But you cannot give the formula of A1 A A12 palm on one file, refer the data in the formula from the other file. So that's the weakness that of this approach. But now you get this data, the new data which more accurate of this is the old data, but now you get the new data over here, which is 3-digit accurate. Okay. Sometimes I want you sometimes you to observe also that if the digit increase, the time takes longer. You might want to observe it also. But it's not hard to expect that certainly it's going to get longer because the data have require more storage to process, right? And if the size keep getting larger, this small increment keep accumulate can result a waste of an increased amount of time execution. Sorry. Okay, so this is the continuation of the homework. Okay, here. Let me repeat it again. I'm sorry. That I'm giving you these two files of solving linear equation, size 2000 by 2000, but partition each part 2000 by 1000, where you expect that your Excel's command of M inverse and M multiplication, metric multiplication, can work quite, still have a comfort zone of response of computing. So, but these two files that I gave you, this one B22, B22, the result, implemented from uh, the idea that we're giving you so far up here. Okay, this one is 2 by 2 for solving equation, and then for to find the inverse matrix we use sheet number 16 here. But all these two files is working in the idea that we put everything in one file. Okay, and then I open another subdirectory, okay, for you on the Excel file. Okay, and then each partition is stored on a separate file. Okay, so what I want you is that to repeat the modify this single file approach to a multiple file approach. For example, for solving equation, instead of you having 6 different sheets under one file, if your data is stored on separate file, you might need 6 separate. You might get what we call no 5. Sorry, because previous this one you need 5 sheets, right? And then for second one you need 8 sheets, right? The same here. That to solve the equation, if by giving you the two right hand side vector b1, b2, you should do it in 5 separate files. And for inverse matrix, the input is also the 4 separate submatrix. The output can be computed in 4 separate submatrix also. Okay, so that's the first part of the lecture for today. Okay, that we continue. Okay, and also provide some example of what we expect you to do from the first homework, and then extended uh, modification idea, okay, to continue to work on the same problem. Okay, now we gonna go back and continue to give you a lectures from the lecture part here. Okay, we now move to the problem of 3 by 3. Okay, if you might recall when you study matrix, right? We normally start with 2 by 2, and now we have 3 by 3. right? This one also we trying to separate, okay, or partition, decompose whatever, the large matrix of psi n by n to submetric of 3 by 3. This partition lead to the 3 partition of the vector x and 3 partition of the right hand side vector b also. And certainly the determinants of A is not equal to 0, leading to a unique solution of X. And N is partitioned to N sub 1 and N sub 2 and N sub 3, right? And it is one in general. A sub ij is a submetric of size N sub I times N sub j. Okay, and then with this partition of Aij, okay, you can get this formula. Okay, and certainly two problems that we're going to attack on based on what we study so far. First, we're trying to solve the equation in the partition form of 3 by 3. The second one is that you want to find the inverse of the matrix. Okay, let's look at follow the footstep as we did for the 2 by 2 system. Okay. Okay, certainly block clouds elimination again. Okay, for the original equation here. Okay, you want to make A11 to become the identity matrix 1, right? And so you use the A11 inverse, multiply on both left hand side and the right hand side of equation 1. You get this equation 4. And with this new formula, right, we're going to call this A12 palm, A13 palm, and B1 palm. Pretty similar to what we did with 2 by 2. And then we're going to use the what we call the block clouds elimination. Okay, we go back here for the second equation. We want to get rid of this A21x1. When we get this equation 4, if you use A21 multiply equation 4 and then subtracting back to equation 2, right? You can see that this one, equation 2 minus A21 multiplied by 4, A21 multiply, the left hand side become A21x1, and A21x1 when subtract from equation 2, it cancel this, right? But A22, no, it's not cancel, because you get A21 multiplied by A12 palm. This is the result, and then you multiply by x2, and then you consider equation 2. Equation 2, you have A22x2. So the result can be A22 minus A21 times A palm 1, 2. This one we call A22 palm. And the same for A23. A23 is equal to the original A23 minus A21 times A13 palm. Okay, this one we call A23 palm. And the right hand side of origin of B2, okay, of B2. Since this one you get A21 times equation 4, the right hand side become A21 times B1 palm, which is equal to A11 inverse times B1. Okay, so and then once you get A21 multiply this, subtract that to the origin value of B2 from equation 2 here. Okay, so you call this B2 palm. Okay. The same for the third equation. You get A32 minus A31 times A12 palm. Okay, because you get A31 times equation 4 and subtract from equation 3 left hand side and right hand side. You get something similar to what equation 5 get, but some index refer to the third equation. Like this one A21 become A31, this one A21 become A31, A22 become A33, A22 become A32, and B2 become B3, right? And so you get the new value that this is a elimination, only x vector x1 left. So you can see that the second equation become A22 prime plus A23 prime A22 prime times x2 plus A23 prime x3 equal to B2 prime, and A32 prime x2 plus A33 prime x3 equal to B3. You can see that the remaining 5 and 6 is similar to what we did before, similar to what we did here. Actually, it become 2 by 2. you can see that actually the 5, you solve 5 and 6, you get a to, you can apply all the thing that you did for the 2 by 2 case, right? So this one just a simplification, right? If you use a22 palm inverse, okay, and then multiply on equation 5, a22 palm inverse here multiplied by equation, this one become x2, this one become a23 double palm, the new a23, which is a22 palm inverse times a23 palm, and this one a22 palm inverse times b2 palm, right? So become equation 7, and then you want to get rid of x2 on equation 6, so you're using a32 palm here multiplied by equation 7 and subtract to the original equation 6. You can see that a32 multiply here, okay, they cancel each other, so x2 no more. The remaining x3 become a33 palm minus a32 palm times a23 double palm. You get this is the new a33 palm x3, so therefore this one is equal to b3 minus a palm, okay. And then once you get a33 double palm x3 equal to b3, okay, equation 8, you can see that you can solve the back substitution. X3 become A33 double palm inverse times B3, okay, and X2 become B2 2 palm, okay, minus A2T double palm times X3. X3 you get from equation here, and then uh, from equation 4, okay, you get X1, okay. In the equation you get x1 become b1 b palm 1 minus a12 palm x2. You move this to the left hand side because you already know x2 from solving back substitution here, and then you know x3 from the origin of the back substitution process, so you get x3 x2 and x1 to get this. Okay, so that is the similar, the extended of the idea of block Gauss elimination when you expanding from size 2 by 2 to size 3 by 3. Okay, and as an IE, industrial engineering, so I just wrote this, write this as what we call the WBS abbreviation from what we call work breakdown structure. We call all the computing activities, and certainly the detail of computing and the predecessor activity that the job the activity that they need to finish before, right? Based on this, okay, based on what we are doing here, okay, on this sheet, sheet 7, and then sheet 8 is just a breakdown of all the computation here. So you can see that you always start with A11 inverse. You see A11 inverse need to compute first, and then you need to compute A12, A13, and B1 palm. You see A12 palm, A13 palm, B1 palm. And all of this cannot be computed if you not finish first step first. So activity number 1 need to be finished first you to get A11 inverse. Therefore you get A12 palm, A13 palm, B palm. Okay. And the next step is, okay, you get equation 4. Equation 5, you need to find A22 palm, A23 palm, B2, A32 palm, A13 palm, A33 palm, and B3 palm. Okay, so that's how we do it. A22 palm, A23 palm, B2 palm, A32 palm, A33 palm, B3 palm. And certainly all of this, okay, you can see that A22 palm cannot be process if a palm 1 2 not compute yet, so activity 5 cannot go ahead and get started unless activity 2 haven't finished yet, but a22 and a21 already available at the first place, right? But just keep in different file. And also 6, also you need a13 palm, so 2 3 4, this one is also wait for b1 palm. Okay, so this one you get a32 33 b3, and certainly they need A12 palm, A13 palm, and B1 palm, which is 2, 3, 4 respectively, similar to 5, 6, 7, right? So after the 10 step, 10 activities here, you already finish this step. equation 6, right? Equation 6. And then you need to update to find the A23 B2 and A33 B3, right? So that's the next step is you get A23, okay? First, you need to compute A22 palm inverse first. You get A22. After you finish activity 5, you can compute A22 palm. And once you get A22 palm inverse, you get A23 palm, right? Double palm, the new A23. And you get B2 palm, A22 palm, according to this formula, right? And equation 7, this one and this one, right? And then this one, sorry. After you get A33 palm, okay, you can see that it's a little bit complicated here, okay. A23 palm, okay, you have to start, you have to find A22 palm first. A22 palm is inverse, you have, which is activity 11, right? But at the same time, you need A23 palm. A23 palm is over here, A23 palm, activity 6. So if 11 and 6 need to be finished unless you cannot compute A23 double palm. The same as B2 double palm. Certainly you need 11, you need A22 palm inverse, okay, and you need B2 palm. B2 palm is over here, activity 7. So that's why these two activities need to be finished. For A33 double palm, you need A33 palm. A33 palm is over here, activity 9, over here. Okay, you have active. And then you need A32 palm. A32 palm is activity 8, okay. Okay, and you need A2T double palm. A2T double palm is activity 12. Okay, so you need these three activity finish, and so you can proceed to activity 14, computing the A2T double palm. So as the B3 double palm, B3 double palm, you need B3 palm, which is activity 10. Okay, and then you need A32 palm. A32 palm is here, activity 8. Okay, and then you need B2 double palm. B2 double palm is here, activity 13. So you need this. And then after you finish activity 15, okay, you reach this point of computing all the block Gauss elimination process. And then the remaining part is to find the block back substitution. Block back substitution over here. Block back substitution start here, right? X3, you get A33 double prime, you get A3 double prime inverse, you multiply by B3 double prime, so 14 and 15. Once 14 and 15 finish, you can get the vector X3. And after you get the vector X3, you're using the back substitution here, okay, X3, back substitution, you get X2. So to compute this, you need B2 palm. B2 palm is here, activity 7. But a lot of time, sometimes you only need this activity 16. Why we don't need to wait for 17? 7, because you look at the 16 is to compute A33 inverse here, right? Once you get A33 double pi inverse, A33 double pi inverse, you already need to pass this, okay? And you need B3 double pi. B3 double pi here, okay? You need you need to pass this one B1 palm here. And B2 palm, yeah, I think that there's some mistake here. This one you need B2 palm. You need to write number 7 here also. Okay, because A23 double palm, okay, you number, no, okay, the bottleneck is X3 first. X3 is number 16, but to get the number 16, you need B3 double palm. And B3 double palm is, you can see that B3 double palm, you need B2 double palm. And B2 double palm, you need B2 palm. So that's why 7 is redundant. Because before you get this B3 double palm, you need to pass activity 7. So you need only 16 here. So the bottleneck is 16 here so that you can finish x2. And the same time of x1. x1 you need b1 palm, you need x2 and x3. x2 and x3 already, if you finish 17 activity 17, you already know x2 and x3. Okay. But a12 palm and a13 palm, you can see a12 is a part that uh, before you get x2 and x3, you need to know these two values. And b1 palm also, that before you get x2 and x3 here, okay? Because x2 and x3 need to find b2, b3, and b2 and b3 also rely on b1 palm. So you don't need this activity 4 again to be predecessor because it's redundant. Okay, so this one is breaking down. You can see that for 3 by 3 system, the problem become more complicated. It's leading to what we call the you go back to the 2 by 2. Okay, only 8 activities. Okay, now we have no, sorry, 18. Okay, activity for 3 by 3. Okay, and the next step is and this one is the inverse matrix. To compute the inverse matrix, okay, this one is a work breakdown structure based on this one, pretty similar to this one. Okay, but this one just write the work breakdown structure here. And we have another homework again. Okay, but this homework is actually already, this is a solution. The later sheet, it was assigned on sheet 9, but the solution is in sheet 10, sheet 11, sheet 12, and sheet 13, 14, and 15, right? Okay. And also we have a similar way of doing on sheet 17 and sheet 18 also. Okay, that can be an alternative for the 3 by 3 inverse matrix. Okay, okay, but for this clip, okay, we're gonna finish you with this results of 3 by 3 case when you partition solving the equation. Okay, not the inverse yet. Okay. The problem for you to think about is that how, if I want to implement this, okay, this concept is already here. Let's break down all of this here with the given file that I showed you before. It's over here, the in the Excel file. Okay, suppose you have A11, A12, A13, A21. This one, the breakdown of 3000 by 3000, let's just say. Suppose I use all this file, this partition, okay, to represent this system. Okay, to represent this system. Okay, but I haven't give you the B value yet. Okay, the B1, B2, B3 value. Uh, Actually, you can go back and use this as a this file. This is the file of solving. You have B1 here. You have B1 here. 1000 by 1000. This one B1. And you get B2 here. You get B2 here. Another 1000 by 1000. This one 2000, right? Suppose I would say, suppose I'm going to create another one like uh, I have maybe I have 2001, and then we have this one plus 1, 2002, and then I keep expanding. Oops, 3000 is too much. Okay. Oh, almost done. Okay, suppose this is 3000, right? I expand to another 3000, and then I think it's up to you. You don't need to use. I'm not gonna put this on the file that I share with you, but you can generate it. Like you might remember, this is the column C according to the right hand side over here. This is B1 and B2 in column C from row number here. Okay, I might say that okay, I'm gonna create another. Maybe we use this. I'm gonna use this formula, 50 plus maybe integers. Oh no, I'm gonna say round. I'm gonna round the number of random. Okay, times 50, and then comma 2. So okay, 2 is mean that we only need 2 digits. Okay, 50 plus another random number. So the smallest value will be 50. The largest value will not exceeding 99.99. Right? So you get this. Okay, they're gonna generate a number for you, and then after that you can okay drag it to this 3000. Okay, and then you might copy, and then you get paste just the number, erase all the formula here. Remember that when you apply this to your sheet program, it's not the value not going to be the same for everyone, right? Because it's a user random number generator. But the reason that I need to copy back to the origin range where the random formula exists is that we only want the real the exact numerical value. We don't want to, because as long as random is there, once you execute one command, you're gonna keep generating the different value. But we want to settle down. Okay, suppose that for me, suppose this is the another 1000 right hand side here. Okay, so now the system become 2000 by 3000, which today we already talked about this, and then we discussed about the approach until you solve the equation. 13 step, 18 step here, 18 activities here. So I want you to this is another additional homework for this clip, is that to adapt this program. Certainly, this program can be worked on two way also that we talked previously. That this one is all in one file. You can do in a separate file, right? All in one file, but different sheet. This one, the one that I share for you. But you can have alternative of not all in one, but partitioned in different file. But the same results is that you need to check the results here. Okay. And one thing that I should mention is that this program of the matrix partitioning that I find, this one, the B11, B12, B1, I haven't checked the result yet whether the resulting file is correct or not. As we told you last time, that we can check it out by using these identities of the matrix here from sheet 3. Oh, here you see that you get A times A inverse is equal to I, right? So if you use this inverse formula here, this is A, this is the A inverse. You get A11 times B11 plus A12 times B21 need to be equal to I1. I think I tell you this about at the end of the first clip that I shared to you before, right? But so there's another open checking for you that is the results correct or not. You can see that in this file, the this file I already checked, right? Left hand side, right hand side equal all 2000. One way is that if you now you know the first question is that now you know the technique, okay, over here to apply for 3 by 3 system of 3 by 3 system. So I just challenge you that with this file that okay, suppose that I extend to be the third part of 1000 by 1000, right? Which we already have a share Excel file. Oh, sorry, over here, right? Previously we work only 4 files: A11, A12, A21, but now you have 9 different files of A11, A12, A13, A21, A22, A23, and A31, A32, and A23, right? So with for the according to solving equation, you need only one right hand side of B3, and this is how I generate it for you. I generated. Actually, you can generate anything that you want to. It doesn't matter. You don't even need to use the formula that I do here. But this one already have a platform of checking the correctness of the solution by balancing both sides of left hand side and the right hand side. But the second program of computing the inverse matrix here, I just show you that I follow exactly the same procedure, the same formula. But I haven't checked the results yet, right? Okay. I think still the problem. If you want to check the result, you need A11 times B12, A times A11 times B11 plus A12 times B21 must be equal to I1, right? And then A21 times B12 plus A22 times B22 have to be equal to I2, right? The 1000 by 1000 identity metric. For the other two multiplication have to be all zero metric of size 1000 by 1000. So that the whole metric you can have A times A inverse equal to I equal to identity matrix. Okay, so you can see that when we come to this point, there's plenty of work, remaining work beyond of what we already did it for you. Still, you can still do a lot more things to add up on this. Okay, so I'm gonna leave all of this, okay, for you to work on and make sure that you submit. This is the second formal homework, okay, is to fill in all the gap that I of the results that we expect to do on this example that I just partially show you some of the results, okay. The remaining part that we talk about, okay, you can do it and then submit, okay, for the collection of your final score. Okay, so now we are in sheet 8 and 9. Sheet 9 is but we leave this, actually this another homework that what about how finding the inverse of the 3 by 3 system. Okay, that but I will show you that from sheet number 10 to sheet number 18 already the solution for you in advance, but certainly we're going to talk about it on the next script. Okay, but for today, okay, I'm gonna end up, okay, finishing the lectures to this point, okay, and if you don't understand much, okay, repeat, rerun, and re-listening, and certainly work on the file on the share drive that I gave to you. Okay, so See you in the next clip.